Alright, in this video, we'll be creating a new model based on the physical modeling here. You know, the difference between analytical modeling and physical modeling, or continuum model and FEM modeling here, okay? So, in here, we'll be having analytical modeling or FEM modeling, FEM model. And in the other side, we'll be having physical modeling or continuum modeling here. Okay, both are same. Well, the main difference in FEM is we'll be using the node-based concept for a drawing here. In the physical model, you'll be using the real world objects. So what's the main difference is if we got a beam column arrangement right in the physical model, it will be column and the beam will be right there to the face of the column right there. So by converting this model into analytical model, we will end up something like this. This will be the center line of the column, and this will be the maybe the structure will be in contact to each other, but for the representation I'll be drawing something like this. This will be the end of the beam. So here I'm representing something as nodes here. Okay, in order to transfer load perfectly from this beam to column, these nodes must have been in contact. So the software decided for a member offset, both seen in Staad tabs and all the other structure analyzing software. So we'll be offsetting this beam the halfway the width of the column here. So the column has width x, so we'll be offsetting this x by 2 right here, so to transfer the load from beam to column here. Okay, so this is one way to convert physical model right into analytical model, but you know, in the real world we'll be using the physical model, and in the software it'll be converted right into FEM model. For the successful transference of load, we'll be having nodes at each and every point. I'll be telling you one more point. I'm having a sort of column right here, and a lot of columns are right there, and the base of the columns are fixed. Okay, if I want to try to draw a beam from column A to column C, I'll be drawing, if you can say, just assume that if I'm trying to picking the first point right on the column A and the second point right on the column B, so you will end up something like this, having a node from 1 to 2 right here without considering node right at B. So the load from the beam will transfer right into this column A and column C, as these two columns are having a sort of nodal connection with this beam right here. So the column B doesn't transfer any sort of load from the beam 1, 2. So what we want to do here is, while drawing this sort of beams right onto the column, we'll be picking up first point and second point on column B, then pick up a draw beam once again and pick up column point 1 and point 2 right here, so that we might feel that this won't be a continuous beam, but actually it's not. For the proper transference of load, each and every node must be there on the column if we are drawing up the beam. So that keeping all these things keeping all these things right in our mind, I'll be drawing up the physical model. It's the first software ever we can draw a physical model right here. Alright, the procedure for drawing is somewhat similar to that of the old method in drawing up in Staad Pro. First, we're setting up grid systems, creating a grid. I'll be drawing this stuff on the XY plane, so by spacing method I'll be providing numbers in 10, okay, spacing Y, or you can have entering the length of the asset. So which one is relative method, and this one is the absolute method here, then total number and number of spaces. Anyways, picking up this first method, I'll be preferring the first method. You can pick up the plane, or again, if one, you can define any sort of UZS right here, which I'm not considering right now. After drawing, we can draw, after picking up grid, we can draw member, beam, surface, okay, anything like here. So picking up member, first point to second point, I got a beam here, first point to second point, first point to second point. Okay, now next thing is I like to assign certain node supports right into this section. So picking up nodes here. Alright, if you select a column, that will be selected. If you pick up on the node, it will be selected. So everything is contextual based on what you click. So I'll be selecting these nodes here. View options are all right here. So you get into isometric view. You can use arrow keys for orbiting. Afterwards, you get into node here. I can have fix support right here. It's so easy to fix the support right there, and you can have a custom support here. You can pick up what and all restraints you want, and spring supports are also here. Okay, that's it. Next, I would like to translate, or I like to assign sort of members right into here. The members shall be assigned. Why the assignment of members is very important, because members have to be assigned to, the stiffness matrix of a beam shall be EI by L into 4224. This one is the stiffness matrix of beam. We'll be providing K. The span will be provided by the section itself. Okay, it's just have the read-only value. Alright, in order to provide the elastic modulus and the moment of inertia, we'll be providing two types. The first one will be the material. I'll be providing maybe a concrete section of beam size materials of I'll be providing a material of concrete having grade M20, and also to define the moment of inertia, I'll be providing maybe the section having the depth of 600 and 230. Alright, so as to filling up all these values for the variable here. Alright, so just get into here, selecting the asset, get into member, and be providing section and be providing materials. Okay, getting to section, you can provide any sort of just get into catalog. You can either, if you wanna to have a steel section, hot rolled, BIS. Okay, man, this is so crazy. What sort of section? ISMB section and all you can provide right here, but right now I'll be providing some sort of a prismatic section right here. In here I'll be picking up, I would like to pick up a solid rectangle. If it's confusing which is Y and which is Z, as I know the Y is the vertical clearance, it should be 600 millimeter, and the other thing will be the width and depth. If you can get into help, I'll be showing you a figure right here. Here, the Z is always lesser. Z is the width of the asset and Y is the depth, and can name the section as section 1 or whatever. Alright, that's it. So currently I have assigned. So currently my software can able to tell what will be the value of moment of inertia. Now let's assign the material concrete right in here. Selecting this asset, can get into member and material. Get into material, I'll be picking up a generic, or if you pick up the generic option, you can enter all the values for alpha, c dam, m dam, all these values to find out the E value right here, gamma, alpha, and all for finding out coefficient of expansion if you provide the thermal load for the structure. Or you can have the custom one. In custom, get into India, I'll be picking up whether you want to have a steel section or a concrete section. Picking up the concrete, entering these values here. Or I can have the standard section from India. It could be like a concrete section which is predefined materials. It can be like maybe M20 or whatever grade you like. I'll be picking up M30. Alright, so E and I are defined it was M20. Maybe you can convert that into M30, I don't know. Alright, so that's okay. Now if you like, you can assign, you can have the translation repeat option here, and also you can have the integrity check, whether the stuff which you've drawn right here is perfect or not. Okay, here I can have next option I would like to pick up is to have the load cases here. So first thing, I can have the load cases. I won't recommend you to pick up the load group, as this one goes to the reference load cases. If you want to have a reference load case, you can get into here load group, but in here I'll be picking up load case. This one shall be a dead load. I'll be only providing a sort of dead load here, and the self-aid multiplier shall be -1. Okay, there's no factors, it's okay. Alright, then I would like to add load, pick up the member which the load shall be applied to. Then I'll like to go to members here, and maybe I would like to have a distributed load from this load case dead, and the uniform load that shall be providing to global y of value maybe -5. Alright, that's it. Then I'll like to pick up get into analytical model. That's all about physical modeling. Let me cross-check everything with the something in Staad. Oh, it's an orphan notice right there, and ignore it. You can pick up orphan nodes here, and you can delete it. Alright, let me see that. Again, how the concrete sections right here, supports or fixed supports here. Getting the loading, I'll be having a sort of, what is it? Okay, self-weight and the other loads right here. I don't know what is this. Alright, okay, alright, then get into analyze. You can add the asset, and I'll like to run the analysis. Alright, that's okay. Let me see what and all are the warnings. Get into post-processing. You can see the structures been deflecting. Okay, well, again, how the moment or torsion is right there, a moment in z direction. This is depending moment on the structure. Alright, if you wanna see values right here, you can get into annotate. I can have the maximum bending moment. I guess you can see that the maximum bending moment is right here. Then I would like to have the most important is graphs here. I can have the bending moment, axial force, and all these things are here. So that's a simple, what you can say, the comparison, whatever you say, you understood what I tried to say. That's it.